Let us look at question number 2a. It says a sequence is such that u1 is equals to p, that means the first term is p, where p is a constant of course, and you are told that un plus 1, okay, is that means any general term should be equals to twice of the previous term, which is 2 times un. Of course, if this is n plus 1, the term before it should be n minus 5, and of course you are told that n must be greater than 0, so it has got to start from 1, 2, 3, 4, 5 and all that, so you can't be having negative terms. So describe how the sequence behaves when p is equal to 7. So if this p, if the value of p, which means u1, if it is equals to 7, so how does the sequence behave? So when p is equals to 7, so what would be u1? Of course it will be simply 7, so we're going to write 7, and now we can use this formula to work out what would be the value of u, okay, 1 plus 1, which is a 2. So u2 would be equals to twice of u1, so twice of u1, from that we can subtract a 5, so 2 u1 minus 5, but of course we already have by u1 in terms of a constant, okay, so that's a 7. So let's replace the u1 with a 7, so we have twice of 7 minus a 5. Twice of 7 is going to be 14, 14 you subtract a 5, and that should of course work out to 9. So from 7 the next term becomes a 9. So what happens when you go to u3? Okay, if you go to u3 and take a look, it would be twice of u2 minus a 5. So twice of, okay, your u2 value which we have worked out in the previous step is equal to 9, so let's replace it. Twice of 9 should be 18, 18 you subtract a 5, and that should be 13. So again it's increasing. Let's look at u4. So it should be twice of u3 minus a 5, so twice of 13 minus 5, and twice of 13 is of course 26, and from that if you subtract a 5 it's becoming 21. And if I just keep continuing, alright, so 7, 9, 13, 21, you can see it just keeps increasing all the way, and of course as I keep increasing all the way right till I reach infinity, that means what would happen to the u infinity? It's going to become very large, right? So it's also going to turn to twice of u infinity. Of course, if the n plus 1 term is a infinity, the term before that must have also been infinity, right? So twice of infinity, subtract away a 5. So of course when you are taking a twice of infinity, it will also be infinity, and from infinity if you subtract a 5, of course compared to infinity, 5 is such a small number, it would still be an infinity. So what happens is, as the sequence begins to increase or become larger and larger, the value will become bigger and bigger, and it would tend towards infinity. So for the part B, you are asked, describe how the sequence behaves when p is equals to 5. So let's put in the value of p as a 5 and see how the sequence behaves. When p is equals to 5, of course the first term u1 is going to be a 5, so u1 is simply a 5, and let's now use the formula to work out the u2. Of course u2 will be twice of the u1, which is in this case is a 5, so twice of 5 minus the 5, so twice of 5 is of course a 10, and from that you subtract a 5, it's going to be still become a 5. So u1 is a 5 and u2 is also a 5. Let's see whether u3 is going to also become a 5. So if I want u3, twice of u2 minus a 5, so twice of u2 is of course which is a 5, okay, because u2 from the previous step is a 5. Twice of 5 once again it becomes a 10, and from 10 you subtract a 5, it's still going to be a 5. So what about u4? It would still be also 5, as you might have already guessed it. So twice of u3, which is twice of 5, and from that you subtract a 5, and that would give you 10 minus 5, which is also equals to 5. So no matter how many terms that you keep, the sequence keeps increasing it to, so the value always remains a 5. So if you go all the way to infinity, and what would it be? It would still be 5. So 5 times the 5, okay, and from that you're going to subtract a 5, so which would still become 5. So when p value is equals to 5, the sequence tends towards a finite value of 5. Okay, what about the part 2? find the value of P for which U5 is equals to 101. Okay, just now we were given the values of P and we needed to find out what is the nth value, or as the term kept progressing. But now we are told to find back the value of P where if the U5 becomes a 101. So of course, to do that we need to make use of the formula. So when P is equals to 5, U1 okay will be simply a P, right, because the first term is a P. So U2 is going to be twice of the P, right, and from that you're going to subtract a 5, and then after that we can start to use the formula. Your U3 is going to be twice of this 2P minus 5, and then from that we're going to subtract a 5. So twice of 2P minus 5 is of course 2 times 2P is a 4P, 2 times minus 5 is a minus 10, and then we have a minus 5, minus 10 and minus 5. If we add them up together, it's going to become minus 15. So that would be the third term. That's U3. What about U4? Twice of U3 minus a 5. So twice of this was the U3, 4P minus 15. We will replace it with that. And from that, let's subtract a 5. Twice of 4P is, of course, 8P. And twice of minus 15 is minus 30. And then you have got a minus 5. So minus 30 and a minus 5 is going to make it into minus 35. So that is U4, but what we need to equate is U5. So we got to go for one more term. So U5 is equals to twice of U4 minus 5, and your U4 is 8P minus 35 from the previous step, and from that we subtract a 5. So twice of 8P is of course going to become 16P. So that will be 16P. Twice of 35 is a 70, and then we have a 5. So it's going to become 16P minus 75. So that is the value of your U5, and that's what you need to equate it to 101, because we are told that U5 is equal to 101. When U5 equal to 101, that means 16P minus 75 should be equal to 101. So now we need to find the value of P. Negative 75, if you throw over to the other side, it's going to become positive 75. 101 plus a 75 is going to give you 176, and then you're going to divide that by 16 in order to give you the value of P as 11. So that is how you find the value of P, okay, and P is equal to 11, and if you do that correctly you will get 2 marks. Let's now look at part B. Another sequence is defined where the V1 is given as A and V2 is given as B, and A and B are told to be constants, and Vn plus 2 should be equals to Vn plus twice of Vn plus 1 minus 7, and of course as usual n must be positive, right? You can't have a negative terms in a sequence. So for this sequence V4 should be twice of V3. So find the values of Vb. Now what is V1? V1 is of course given as A, so that's V1, and your V2 is given as B, okay, it's also given to you. Now what would be V3? Of course that's where we need to start using this formula. So when n is if you put in n as a 1, so V1 plus 2 will become 3, that's V3, should be equals to V1, okay, plus twice of V2, alright, because 1 plus 1 is a 2, so twice of V2. From that we minus a 7. So now we have V1 and V2 in terms of A and B. So let's replace the V1 with A and V2 with a B. So we have a A plus twice of B minus 7. That should give us what is V3. But for us to make use of this given equation, so we need to go for one more term, which is V4. So our V4 should be equals to, again we're going to use this formula, but this time instead of V1 and V2 is going to become V2 and V3, right? So V2 plus twice of V3 minus 7. So we have the V2, okay, which we can take it from here and substitute, that's a B, and then plus a twice of this entire expression, which is for V3, and then minus a 7. Let us simplify. So we have got 2 times A, 2A, and then 2 times 2B is going to become 4B plus 1 more B, that would make it into 5B, and then twice of minus 7 is minus 14, and then from that you minus another 7, that should give you minus 21. So this is the value of your V4. Now we can start to apply this. V4 is equals to twice of V3, since we are told that. So since V4 is equals to twice of V3, and this is my V4, 2A plus 5B minus 21, and this should be equals to twice of 2 times your v3, which is a plus 2b minus 7. Okay, so now we can actually expand this and find the values of b, or the value of b. So let's expand the right hand side. Twice of a, okay, this part is 5b, okay, minus 21. Okay, here you have a twice of a. Of course, here you have a twice of a, here also you have a twice of a. So we can cancel the twice of a. So what you will have is 2 times 2b, which is 4b. 2 times 7, that should give you the 14. So 5b minus 21 should work out to 4b minus 14. Next, let's bring all the b's to the one side, and let's throw all the constants to the right hand side. So 5b, if you subtract the 4b, and that's going to give you just 1b. Negative 21, if you throw to the right, it becomes positive 21. From that, if you subtract the 14, and that should leave you with a 7. Therefore, the value of b is simply 7. Let's look at part 2 now. It says, find an expression in terms of a for v5. Okay, so this time we're going to go for, just now we went up to v4. Now we want an expression in terms of a for v5. So our v1 was a, and our v2 was 7, because just now from the first part we worked out v2 was a b, and the value of b, just now we found out if this term is if this condition is satisfied, your v2 became a 7. So don't use b, so we're going to use 7. And then our v3 is, of course, okay, is v1 plus twice of v2 minus 7. And if we were to put in the v2 with a 7, so a plus twice of 7, that's a 14. From that you subtract a 7, that's going to become a 7. So that's your v3. And your v4 should be v2 plus 2v3 minus 7. I'm using back the same expression. So your v2 is simply 7 now, and twice of v3 we're going to use a plus 7 as the v3. So 7 plus twice of a plus 7 minus a 7. So twice of a is a 2a, and twice of 7 is a 14. We could cancel the plus 7 and a minus 7, and that should finally work out to 2a plus 14, and that is the v4. But what we need now, okay, do we stop here? No, we need to go on one more term, which is v5. v5 is equals to, okay, v3 plus twice of v4 minus 7. Our v3 we already have is a plus 7, and twice of v4, which is in the bracket we put in 2a plus 14, which is here, and then minus a 7, and 2 times 2a is going to be 4a plus one more a, that's going to become 5a, and twice of 14 is a 28, right? And then here we got a plus 7, here we got a minus 7, which would cancels out, okay, and twice of 14, that should give you 28. Therefore our v5 is 5a plus 28, and we have expressed v5 in terms of a as needed by the question, and that should give us 1 mark. Okay, let's look at the part C now. The part C says the sum of the first n terms of the series is a cubic expression n cubed minus 11n squared plus 4n, where n is a positive integer. Find an expression for the nth term of this series. Okay, this is the sum of first n terms. This is not the nth term, this is the sum of the first n terms. So what we want is the expression for the nth term of the series, giving you answer in its simplest form. So how can we approach this? If sum of first n terms is this, and if, let's say, if I take out the sum of the first 9 terms, so I'm going to get just the 10th term, right? So if, let's say, you want to find the 10th term, so you take 1 to 10, okay, and you sum them all together, and then you take 1 to 9 and you sum them all together, and you find the difference. That will just give you the what is the 10th term. So we're going to use similar kind of method to find what is the nth term of this series. So let's write down, let sum of n terms be called this, since we are given that n cubed minus 11n squared plus 4n. We're going to find the sum of one term before that. What would it be called? N minus 1. So sum of n minus 1, of course every one of the n over here is going to be replaced with n minus 1. So n minus 1 cube, 11 times n minus 1 squared plus 4 times an n minus 1. And if you were to expand this, so we're going to end up having n cube. Of course you can use binomial expansion, or you can just simply perform a squaring and then expand it once more with n minus 1. So if you expand this first bracket, it's going to become n cubed minus 3n squared plus 3n and a minus 1. And then this part is simply a quadratic expression, so n squared minus 2n plus 1. And the last one is just simply a 4n minus 1. So we can simplify this further. So we got a n cubed, that is only once. There's a minus 3n squared. There would be another minus 11n squared. So we can combine them together. Okay, so what I have done here is just expanded the second bracket to write down here and the third bracket to write down here. So now we can regroup and simplify, and that should simply give us n cubed minus 3n square and a minus 11n square makes up minus 14n squared. We have got a 3n and a 22n, and that should be 25n, and to that we add another 4n, that should give us 29n. So we got a negative 1, negative 11, that is a negative 12, negative 12, negative 4 is going to give us negative 16. This is the sum of n minus 1th term in terms of n. Now let's find out what is the nth term. Okay, so if you want to find the nth term, so you're going to just take sum of n terms, and then from that you're going to minus away sum of the n minus 1 term. Okay, the sum of all the terms just before the nth term. So Sn is this, so n cubed minus 11n squared plus 4n, and from this we're going to subtract away sum of the n minus 1th term, say sum of n minus 1 terms, so which is this, and then we can see n cube and minus n cube, we could cancel them, n cube minus n cube, so we got a minus 11n squared, minus minus is going to become plus 14n squared, so it's going to be simply 14n squared minus 11n squared, which is going to give you 3n squared. We have got a plus 4n minus plus is going to give you minus 29n, minus 29 plus 4 is going to give you minus 25n, and then as far as the constant is concerned, minus minus is a plus 16, and this is the expression for the nth term of this series. So we have given the answer in its simplest form. I don't think you can factorize or simplify any further. Just leave it like that. Now let us look at the part 2. The sum of the first m terms of this series, and we are told where m is greater than 3, is equal to the sum of the first 3 terms of this series, and we need to find the value of m, sum of the first m terms of the series. So how do you write that? So this is sum of first n term is given by this, so if you change the n to a m, so sum of first m terms would be equals to m cube. I'm just changing all the n to m cube minus 11m squared plus 4m. This is the sum of the first m terms of the series is equal to the sum of the first 3 terms of the series. Sum of the first 3 terms means S3, right? So sum of the first 3 terms. So how much would it be equals to? Of course, we're going to replace the n's with 3. So it's going to be 3 cube minus 11 times 3 squared plus 4 times 3. And if you press this into the calculator and you press the equal button, you should get minus 60. And we are told that this is in fact equals to minus 16. So given that Sm is equal to S3, so let's equate them. That's your Sm. And if you equate it to minus 16, and then you can throw the minus 60 over to the left side, you get a nice cubic expression. Okay, is equal to 0. And of course, you could use factor theorem to factorize it, or you can simply use a graphic calculator. Okay, and you should be able to find the solution. So m plus 2, m minus 3 and m minus 10 are the factors of this cubic expression, and this should be equal to 0. So therefore, what are the values of m? So m can be equal to negative 2, but of course, is this value to be accepted? You should look back at the condition. M must be greater than 3. So later we're going to reject this value. And if you look at this, m is equals to 3. Of course, m cannot be equal to 3 because the question says m must be greater than 3. So m equal to 3 will also be rejected. The last value is m could be equal to 10, and of course that should be the answer. M equal to 10, and of course m is equal to 3 is also rejected. So the question therefore asked you find the value of m, and therefore the value of m is just simply 10. So that's how you solve the C part 2.